topic for our presentation is business model innovation, in which we are introducing lithium-ion batteries in Pakistan, and our group members are Ali Fawad, Abrar Ali, and Zain Zafar. The company that we are working on is Energy Solutions Private Limited, which is one of the leading power generation companies in Pakistan, and they deal in diesel, gas, and gasoline generators, UPS, and solar power systems. And the problem that they're currently facing is that the market trend they've observed is shifting more towards the renewable energy resources, primarily solar and wind. And the customers, especially the telecom sector, BTS sites in which a lot of their diesel generators are installed, those customers are looking for solutions that are independent of fuel, that is fossil fuel. And the problem that they're facing, those telecom sector, is these diesel generators have periodic maintenance issues, and the BTS sites are mostly located in the remote and hilly areas. So doing maintenance of these generators periodically and supplying of fuel to those generators is one of the issues with telecom sector, for which because of which they want to look for solutions that are independent of fuel. The solution that we can come forward with for the telecom sector BTS sites is the introduction of lithium-ion batteries, which could easily replace those diesel generators. And as we know that those telecom sectors have thousands of unmanned base transceiver stations, that is, there's no operator who is 24 hours working over there, because they're very remote and hilly areas in which these sites are located. So lithium-ion batteries can easily replace those diesel generators over there. How it can be done is that the lithium-ion batteries will be charged through solar panels in the daylight, and for the night portion of the day, lithium-ion batteries has a very long battery life and a very high duty of discharge cycle, which is enough to power those BTS sites in the night as well. So what actually is a base transceiver station? As you can see over here in the pictures, it is a device that facilitates the wireless communication of the user equipment in the network. And in Pakistan, currently around 40,000 BTS sites are operating, and these numbers are expected to double in the next 5 years. And obviously, the unmanned BTS sites will also increase accordingly. Difficulty in carrying out routine generator maintenance is one of the key issues over here. And as generator maintenance is a hassle, it also adds up to the cost of maintenance. With the introduction of lithium-ion batteries, there are some other prospective customers also highlighted over here. Apart from the telecom sector, which are the existing customers, there are some huge data centers in the banking industry, in the telecom industry, and in the various other IT sectors. These huge data centers can absolutely not tolerate any power breakdown, and they're currently using UPS as an emergency backup supply, which relies on lead acid battery technology. Now we all know that lead acid battery technology can easily be replaced by lithium-ion batteries because of the fact that lithium-ion batteries have a very high energy density and very long backup hours, and are more reliable than the lead acid batteries. Apart from data centers, electric vehicles, we all know, is the next evolution in the automobile sector and is just around the corner. So the best suitable battery for the electric vehicles that is up till now being proposed is the lithium-ion batteries, because of its long backup hours and also because of its fast charge time. Some of the key features of lithium-ion batteries are that it has the highest energy density, which means that it has the highest amount of energy that a battery can contain. Then it has very low internal resistance, that it can deliver high current when there are peak demands of load, and the battery would absolutely remain cool. That is, it has the acceptability of wider temperature ranges. Then it has a very high cycle life, that is, the lifespan of lithium-ion batteries is very large. It has the fastest charge time, that is, it requires less than an hour to charge. And then it has a very low self-discharge, that is, when the lithium-ion batteries are not connected to any load, it won't be discharging on itself. Then there is no maintenance required in lithium-ion batteries, and there's no toxicity. That is, when it disintegrates, it does not toxic the environment. So this table defines the technical comparison of different types of batteries. And one thing to be noted over here, that this comparison is on the average rating of all the batteries. That is, it was not possible to make a comparison of each rating. So therefore an average rating was considered, and this comparison was drafted. Now let's see that first of all, energy density. Energy density of lithium ion batteries is the highest as it was observed previously. The internal resistance is not the lowest one, but it is quite considerable. Then the third thing is the cycle life. That is, the lithium ion batteries has about 2000 cycle life on average, which is way much better than the lead acid, nickel cadmium and nickel metal hydride. That suggests that it has the long lifespan. Then it has the fastest charging time, less than an hour, and it has a self discharge per month. That is, if it is not connected to any load, then only 2% of self discharge per month will be observed in lithium ion batteries compared to the other options. Then it is completely a maintenance free battery, lithium ion battery. As you can see, the other batteries requires periodic maintenances. And toxicity, you can see that very low toxic nature is of the lithium ion battery. This table defines the cost comparison of different types of batteries, and again it has been done on the average rating of different types of batteries. Now considering the first point is the typical battery cost. As you can see, the lithium ion battery has the highest battery cost available in all the categories, but if you compare it with the cycle life, it has the longest lifespan as well, which suggests that the cost per cycle of lithium ion batteries is only 0.05, which means that if you consider the capital cost of the batteries, then lithium ion might be the most expensive one. But if you consider the entire life cycle cost of all the batteries, then lithium ion would be the most cheapest option available. One thing more to be considered is that the maintenance cost is not included in the cost per cycle. That is, the lead acid, nickel cadmium and nickel metal hydride batteries have maintenance costs, which will be added in the cost per cycle as well. But in case of the lithium ion batteries, there is no maintenance cost since it's a maintenance free battery. This is a prototype of a lithium ion battery which is powered by solar panels for the BTS sites. The two solar panels are connected in series, which are then in turn connected to a charge controller, which then in turn is connected to a lithium ion battery. As you can see, the solar panels, they take up the solar energy and they send it to the charge controller, which then charges the lithium ion battery. The sole purpose of charge controller is to prevent the lithium ion battery to get overcharged. So it is one of the most important component in this scenario. The power requirement for the BTS sites of the telecom sector is approximately 10 kilowatt, which could be 14 or it could come on to 8 as well. But all those requirements can be met by increasing the number of panels. This power requirement can easily be met, as already discussed, because of the high energy density and the high duty of discharge of the lithium ion batteries. And since no overhauling or maintenance is required, it is one of the ideal solution replacing diesel generators. This is the prototype of lithium ion batteries that can be used for the UPS in data center applications. And as you can see over here, that lithium ion batteries have a very reduced footprint, because of which the building modifications and the cooling requirements cost is entirely reduced for a UPS to be placed. Then it can withstand wider temperature ranges, which is a very important feature for a UPS application. And UPS application also comes around with the battery monitoring system, which is not a feature of the lead acid battery. So lithium ion supports that system, which is an advantage for the UPS application. Then battery life for the lithium ion batteries is more than 10 years, again reducing the burden and cost of battery replacements as well. So lithium ion batteries provides one of the best suitable support for the electric vehicles, in which it eliminates the concerns of thermal runaway. That is that when a battery of lithium ion type, which has long battery backup hours, are prone to explode in heated conditions, which can cause serious accidents. So lithium ion eliminates that concern Then it also provides a guarantee of 10 years or 160,000 kilometer of running, and performance reliability in variety of temperatures, whether it is extensive extreme summer heat or freezing temperatures.